Okie in this video, we will be covering all 16 questions on the Unit 1, Exam 1, review, practice test thing. Let's get into it, starting with number 1. They say a manufacturer of tennis rackets finds the total cost manufacturing X rackets a day is given by this. So again, this is the cost. Each racket can be sold at a price of P dollars. So this is the price. They say find an expression representing the profit, assuming that all the rackets manufactured can be sold. Hint, the total revenue is given by total number of rackets multiplied by the price of each racket. And then the profit is revenue minus cost. So what they're telling us is revenue is price times quantity. And profit is revenue minus the cost. So what do we need? We need the revenue, which is price times quantity. And in this case, quantity will really just be represented with X. So X represents the number of rackets. So what we're going to do is find our revenue by multiplying the expression for P by X, because X is our quantity. So P is negative 0.0004x plus 9. A little jam-packed there, but we are distributing an x here and here. So we have negative 0.0004x squared plus 9x. That is our revenue. Now we need to find profit by doing revenue minus cost, so that is just this revenue minus the given cost right there. So we'll just write this, I guess, down here. Negative 0.0004x squared plus 9x minus, in parentheses, 0.0003x squared plus 4x plus 500. All right, so what this means is, really, we're pretty much done, I guess, but they tell us to simplify our answer completely. So we do have to combine some like terms and just simplify it, and then we'll be done. So we are doing this x squared term minus this x squared term. So basically, negative 4 minus 3 is going to give you negative 7. And so we go negative 0.0007 x squared. We have an x term here, 9x minus 4x. Think about the negative getting distributed to these three terms. So 9 minus 4 is 5x. And then the negative gets distributed to the 500. So this is the expression which should be on this side of the equation there to represent our profit. Profit's revenue minus cost. Revenue is price times quantity, and you were given the cost in this case. All right, that was number 1. Here's number 2. Perform the indicated operations and simplify. So starting with 2m plus 2 squared, whenever you see this, do not just square each of those terms, 2m and 2. You have to think about it as if it were 2m plus 2 times 2m plus 2. And so we must not just square the first term and the last term, but also get the in-between terms from basically like foiling it out. Make sure you got the lobster claws, okay? Lobster claw here, lobster claw there. Okay. 2m times 2m is 4m squared. 2m times 2 is 4m. 2 times 2m is another 4m. 4m plus 4m is 8m. 2 times 2 is 4. If you want a shortcut in the future, if you have any binomial, any two-termed expression squared, square the first term, square the second term, and then multiply the two terms and multiply that by 2. So multiply the two terms. 2m times 2 would give us 4m, times 2 is 8m. So we have first term squared, last term squared, both terms multiplied together, times 2. Okay? A little bit of game for you there. All right, let's get rid of the lobster claws and keep expanding what we have here. So we have negative 5m times 1 minus m. So we need to distribute that. So we have minus 5m. And then we have negative 5m times negative m. So that's plus 5m squared. And then just minus 4 on the end. what can we combine here? We have an m squared and an m squared, so we have 4 plus 5, that's 9 m squared. We have an 8 minus a 5, so that's plus 3m. And then we have 4 minus 4. Those are gone. So 9m squared plus 3m is our final answer. All right, let's keep going with number 3. They tell us to factor this polynomial. If it's prime, enter prime. Okay, what you need to notice right off the bat is that these two expressions are perfect cubes. These are perfect cubes, which means we need to factor a sum of two cubes. So it might help knowing for the test the formula or the factors for a sum of two cubes and maybe also a difference of two cubes. So for the sum of two cubes, a cubed plus b cubed, it'll be a plus b times a squared minus, might need to make, no, I have that right, yeah. So a squared minus ab plus b squared. So this is the formula for a factor, or for a sum of two cubes. So we have to identify what our a and b are. So keep in mind, if 27m cubed is our a cubed and 1 is our b cubed, well, if b cubed is 1, hopefully it's clear that b is equal to 1 because the cube root of 1 is 1. But then the cube root of 27m cubed, so if 27m cubed is a cubed, then that means a is the cube root of 27, so 3, but also the cube root of m cubed, m. Okay, so a and b. So now we just plug them into the factors up here and we should be done, I believe. So we'll have 3m plus 1 and then 3m squared. So 3m squared you could write out like that, 3m squared, or you could go ahead and square it. So 3m squared would be 3 times 3, which is 9, m times m, which is m squared, minus a times b, so minus 3m times 1, so 3m, and then plus b squared, which is 1 squared, which is 1, and that's all we can do. We're going to leave it just like that. Those are our factors for number 3. Again, that was a sum of two perfect cubes. It might help to also investigate a difference of two cubes. Very similar formula, except there's subtraction, and then this part is addition all the way through. Okay? Okay, number 4. Factor the polynomial. If it's prime, enter prime. Okay. First thing to check for every time is for a GCF. If you can find a GCF, a greatest common factor, that you can pull out of all three terms, then do that. But in this case, we cannot. So we want to treat this as if it were just basically a 2u squared plus 5u minus 12. And then we can kind of just bring the v's into the mix towards the end here. So yeah, so I'm going to treat it as if it's just this first. And so the way I would go about factoring this is by using the slide and divide method. So I'm going to take this 2, multiply it to the 12. We're going to get u squared plus 5u minus 24. And then we're just going to factor this like we would normally. So I'm going to get two numbers that multiply to negative 24 but add to 5. So I was thinking 8 and 3, but that actually doesn't. Does that make sense? Oh, that does make sense. I'm tripping. Yeah, so we'll do plus 8 minus 3. Yeah. Okay, u plus 8, u minus 3. Negative 3 times 8 is negative 24, and 8 minus 3 is 5. So we cannot forget using the slide and divide method to not just slide, but also divide by the 2. When we do so, if it divides nicely, like the 8 over 2, we are left with u plus 4. We want to just divide it nicely and leave it like that. If it does not divide nicely, as in the 3 over 2, we're going to bring that 2 out in front. So we'll have 2u minus 3. Now, these are the factors, again, of this. So all we need to do is introduce the v here, the v squared here, which means we actually just need to tack on v to the two factors we have here. And that these should be the factors for this polynomial expression. If you are ever unsure about your answer, you can always multiply these out to see if it actually gives you the original expression. Let's give it a shot. U times 2u is 2u squared. U times negative 3v is negative 3uv. 4v times 2u is 8vu, or uv, and 4v times negative 3v is negative 12v squared. And this would give you exactly what we had originally. So these, again, are our factors for number 4. Number 5. They ask us to perform the indicated operations and simplify. So notice we have a bunch of very factorable expressions here, divided, first of all, in fractions, and then they're dividing the two fractions. So first thing I'll say is, let's go ahead and rewrite the division of this fraction or quotient as instead the multiplication of the flip of that fraction. So I'm going to just flip this fraction so we can like multiply by this fraction instead of dividing by the original fraction. Okay, make sure I got the signs right here. Okay, so now we're just going to ignore all of this because we have flipped it and changed the sign to multiplication. So keep, change, flip, if you will. So now what we are doing is multiplying this fraction by this fraction. And in order to do so, it's going to help to factor every single polynomial that we see here. So hopefully all these are very factorable. So starting with upper left, k squared minus 3k minus 4. Two factors, multiplying to negative 4, adding to negative 3. We have minus 4 plus 1. Let's keep it going. Below that, we have k squared minus k minus 12. So k minus 4 plus 3 minus 4 plus 3. Multiplying to negative 12 but adding to negative 1. Cool. Now, the beautiful thing is when we multiply by another fraction, when you multiply two fractions, you're just multiplying across the tops and multiplying across the bottoms. Numerators, numerators, denominators, denominators. So what that means is when we factor this k squared minus 5k minus 24, we can just throw those factors in the same numerator as the k minus 4 and k plus 1 up top. So factoring this, we get k minus 8 and k plus 3. I think we had something similar in the last problem, just flip-flopped, I think. So minus 8 and plus 3. Then below that, we should have very similar, actually. We'll have k minus 8 and k minus 3. So that they multiply to positive 24 but add to negative 11. Okay, now that was the hard part. Now the fun part is just canceling anything out that shows up on top and bottom. K minus 4s, k minus 8s, k plus 3s. What are we left with? K plus 1 over k minus 3. And we are done. That's all there is to it. So big things on this one. If you're dividing by a fraction, change it to multiplying by the reciprocal. And if you have factorable expressions, go ahead and factor out everything so that you can cancel things out. Okay. That was number 5. Here's number 6. We got a mamma jamma here. They say perform. One sec. Perform the indicated operations and simplify. So we have three fractions being added and or subtracted together. In order to add or subtract any fractions, you must have a common denominator. So let's figure out first what that common denominator is. Then we can initiate like making all of them have the same denominator. So in order to do so, I'm going to rewrite the first fraction so that its denominator is factored out. So the y squared minus 9 can be factored into y plus 3 and y minus 3, because that is a difference of two squares. If you have a squared minus b squared, the factors are a plus b and a minus b. Okay, so what do we notice? We notice that this is probably going to be our common denominator. Why? Because y plus 3 is in a different denominator, and like this denominator already has y plus 3. And notice this one's kind of close, but it's slightly different. So we'll talk about what to do with this in just a sec. But I'm going to keep writing this out. So the second fraction we don't need to do anything with. I'm just going to leave it as y minus 3 over y plus 3. But I will leave a little bit of space because we're going to do some multiplying next to it in a sec. Now, for the last fraction, I'm going to factor out a negative from the bottom. And I'm going to factor out a negative from the bottom and negate the 3 and the minus y. So it's going to become a negative 3 and a positive y. In other words, positive y and a negative 3. In other words, it's giving us a denominator of y minus 3 as long as we take care of these two negatives and make this addition for the operation. Now what do we notice? We have three denominators where the common denominator should likely be this here. That's the goal we're working towards. So this fraction, this denominator, is just missing y minus 3, which means we multiply on top and bottom by y minus 3. This fraction over here, what is it missing? Y plus 3. And so we multiply on top and bottom by y plus 3. So this was sort of the efficient way of finding and getting a common denominator all across the board. So now we can have just a single denominator, y plus 3, y minus 3, and then we can just perform the operations with the stuff that we have on top. So we have a y to start plus y minus 3 times y minus 3. I'm going to go ahead and expand all that because I have a feeling a lot of stuff is going to simplify up top. Y minus 3 squared is y squared, so y times y. Both terms multiplied, so y times negative 3 is negative 3y times 2 is negative 6y. And then negative 3 times negative 3 is plus 9. And then we have 2y times y plus 3. Distribute that, we get 2y squared plus 6y. Okay, we're on the home stretch. What can we simplify up top here? We have a y minus 6y plus 6y. Well, I'll just say the 6y's cancel each other out. And then, so we're just left with y. And then we have a y squared, 2y squared, so that's 3y squared. So let's write a final answer here. We got 3y squared plus y and then plus 9. And I don't think we need to go any further than that. We can leave it just like this. And that should be good. So we found a common denominator with the help of factoring and multiplied what we needed to those fractions to make sure we had a common denominator, and added everything together, distributed, combined like terms, cross things out. Yeah, that was number 6. Here is number 7. They say simplify the expression and write your answer using positive exponents only. All right, I would recommend starting with this. What we'll do is distribute the negative 3 to the 3 to the negative 1 and to the r to the third. What that will look like is 3 to the negative 1 times negative 3. So you multiply the exponents and get positive 3. And then r cubed times, r to the 3 times negative 3 is negative 9. 3 times 3 is negative 9. So then do the same thing here. Distribute the 3 to the 3 and the 3 to the s to the negative 1. So what that looks like is 3 to the third and then s to the negative 1 times 3. So that is negative 3. Okay, so what can we do? We can do 3 cubed twice and we get 27 and another 27. So 27 for this one, 27 for that one. And I'm going to start doing something with these terms with negative exponents. I'm starting to create a fraction because if you have r to the negative 9, that's going to be the same as r to the 9th in the denominator. And if you have s to the negative 3, basically up top, it's going to go in the bottom as s to the positive 3. And we're pretty much done at that point. We just need to multiply 27 times itself, and that will give us 729. Over r to the 9th s cubed, and that's our final answer. Okay. Number 8, simplify the expression and write your answer using positive exponents. Okay. First thing I notice right away is -2 times -2 in the exponent. That's just going to give us a big ol' 4. So just all this stuff to the 4th. Okay? Now, we have a y to the 0. That's just 1. Anything to the 0 is 1. So like all this stuff times 1, we can just neglect it. It's not going to change anything if we just cross that out. What else can we do? It's really up to you, really, at this point, like what order you want to do things in. I might simplify what's on the inside a little bit first, then, maybe not. I don't know, man. So I'll go ahead and say this. We have a negative to the 4th power. The final answer is definitely going to be positive. So that's all you need to do with that sign. I'll go ahead and just do our same approach we did last time. Distribute the 4 to the exponent. So we'll go 2 to the 2 times 4, so 8. X to the -3 times 4 is -12. And then same thing on the bottom. 3 to the 2 times 4 is 3 to the 8th. X to the 4 times 4 is x to the 16th. Y to the -2 times 4 is -8. Now, and then it's positive, so I'm just going to get rid of that. 2 to the 8th is whatever it is. I don't know. 16 times 16. 256. And let's talk about the x's here. A couple different ways you could look at it. If you see an x to the something divided by an x to the something, if you prefer like using the rules where it's like a minus b, you can do x to the -12 minus 16. You subtract the exponents. Or you could have like moved the x to the 12 to the bottom, and then you would have had on the denominator x to the 16th, x to the 12th. So you just add the 16 and 12 and get 28 on the bottom. Either way, we get... Sorry, I can't cancel this out. Let's write it down here. 256. Either way, you get an x to the 28th in the denominator. Now, what else have we not dealt with here? Well, we have a 3 to the 8th. What the heck would that be? That's 9 to the 4th, which is 81 squared. So that's 6,561. Okay. And then the y to the -8 on the bottom can go up top as y to the +8. And then I don't know if those can simplify. I don't think 256 over 6561 could simplify because they have all different factors. So if you have 2's on top and 3's on the bottom, there's no like canceling anything out, right? So I think this is our final answer. It's a little lopsided, but 256 y to the 8th over 6561 x to the 28th power. Okay? All right. That was number 8. Here is number 9. Solve the given equation. Okay. All right. I might recommend the approach of cross multiplication. You could also take the approach of like getting everything on one side, finding a common denominator. It's kind of doing the same thing. I'm just going to do it anyway. Or I'm going to do, cross multiplication anyway. So I'm going to multiply this up and multiply this up. So basically multiplying both sides by 7x plus 6 and 7x plus 5. When we do so, we get 7x plus 5. I'm going to zoom in, hope you don't mind, times 9x minus 5 equals 9x minus 7, plus 7, times 7x plus 6. Let me make sure I have the signs right here. 9x minus 5, 7x plus 5, 9x plus 7, 7x plus 6. Good. Now, we got to distribute everything, multiply everything out. 7 times 9, 63, x squared. 7 times negative 5, so negative 35x. 5 times 9 is 45x minus 25. 5 times 5. And then equals, oh, that's lovely, 9x times 7x, 63x squared. 9 times 6, 54. X, 7 times 7, 49. X, 7 times 6, 42. Okay. What can we do? Well, we can subtract the 63x squareds off both sides. Now I'd probably just start chipping away. Negative 35 plus 45 is 10. X minus 25. Got 49 plus 54, that's like 103. Yeah, 103x plus 42. We'll subtract 10x, we get 93x equals, this looks stupid, minus 42, so negative 25 minus 42 is negative 67. Okay, and then divide by 93, so negative 67 over 93 equals x. That is stupid. Okay, I do have to check to make sure that's right, because that just seems a little insane. Okay. Yeah, we're going to give it a shot. We're going to go to Desmos as fast as we can here. Let's give it a go. So, we're going to do, I'm just going to type each thing and then you'll see what I'm doing. So, each fraction, I'm going to use A instead so I can do a slider. So, the first fraction, we'll do the second fraction. Alright, so if we set, theoretically, A equal to negative 67 over 93, these should equal the same thing. And they equal negative 12. That is the same thing. Alright, I'm going to have to say that's the answer then. So that should work out. Negative 67 over 93. Hopefully that's the only solution. I'm curious if there might be a second solution. I'll have to check that at the very end. I don't have time to go into that right now. What I'm getting at is maybe if we subtracted this fraction onto the other side, found a common denominator. I'm curious if there'd be one. I don't know. I'm not going to dive into it now. We'll see. So, given the equation, I wonder if I could just grab, I'll worry about it later. Let's do number 10. Solve the given equation. So we have fractions added together, different denominators. So I would recommend you go about a couple different ways. You could multiply the whole equation by the common denominator, but you still have to find the common denominator. So let's do that. 3, 16, and 12. Okay, well, if you have 3, 16, and 12, what factors do they share? Well, 16 is just a bunch of 2's. It's 2 to the 4th. 3 is just 3. 12 is a 3 and 2 squared. So we need a little bit of everything. We need a 3. We definitely need 4 2's. And 3 and 4 2's already has a 3 and 2 2's. So this is like the least common multiple, in other words, the least common denominator of these three denominators here. So 3 times 16, so that's 48. So we could find a common denominator, 48, and just like treat them all like fractions, but really the trick here, what I would recommend, is multiplying the entire equation by 48, by that least common multiple. What this is going to do is get rid of all the fractions and just leave you with like a simple algebra problem. So 48, 48, 48. 48 divided by 3 is 16. So you have 16 times w minus 1. 48 divided by 16 is 3. So you have plus 3 times w plus 1. 48 times negative 12, or sorry, 48 divided by negative 12 would be negative 4. So then times w plus 1. Okay. Here's a fun thing. If we have this equation to work with now, you could distribute everything, but notice this is w plus 1, that's w plus 1. These are like terms. You can do plus 4 w plus 1s on both sides here. So it'll get rid of those 4, and you'll actually have 7 w plus 1s on this side. Did that save us time? I don't know. But this equals 0 now, and now you can just keep working it out. You're going to still have to distribute it anyway, so go ahead and distribute it from the start. Don't listen to me. Let's do 16w minus 16 plus 7w plus 7 equals 0. Let's combine the w's, 23, and let's combine the numbers but then move them over. So 7 minus 16, that's hurting my brain right now. Why is that hard? Is that 9? Negative 9. Yeah, so negative 9 on the left side, but when we add that over, that's going to be positive 9. So we divide by 23, and we get w is 9 over 23. That's crazy. I hate having to keep checking these, but I feel like I have to if I want to provide you with the correct answers. So I'm going to go w minus 1. So I'm going to do, I guess, a minus 1 over 3 and plus a plus 1. But that part is going to be over 16. Add a slider. And we'll do negative in parentheses w plus 1, so a plus 1 over 12. And our answer was 9 over 23. Let's test it out. Looks good to me. It's a crazy decimal, but they're both the same crazy decimal or crazy fraction of negative 8 over 69. So that does mean 9 over 23 is our solution. All right. That was number 10. Here is number 11. Write the equation in simplest radical form. There's a negative on the outside and a fourth root, and that is okay. If you had any even root of a negative number, in other words, if it was the fourth root of negative 162, that would not exist. But this is totally fine. It just is saying the answer will be negative. So we're finding the fourth root of 162, basically. Fourth root of 162. How can we go about this? Well, we want to break it into factors. If we can do it, ideally, we break it into 2 factors, where one of those factors is a perfect fourth. So like 16. 16 is 2 to the 4th. Or 81. 81 is 3 to the 4th. And that might be it. So 81, I realized, is just half of 162, which means 81 times 2 is 162. And again, 81 is a perfect fourth, or whatever you call it. So fourth root of 81, we take our perfect fourth root of that, and we get 3. So 3 comes to the outside, but it leaves that 2 on the inside. And again, it started with a negative in front, so we're going to leave a negative in front. Negative 3 times fourth root of 2. Okay, that was number 11. Hope this makes sense. We got just a few more problems. I hope this video recording is hanging on just fine. 34 minutes. Pretty crazy. All right, let's keep it going. Number 12. Rationalize the denominator of the expression. So what this means is we need to multiply by the conjugate. We need to multiply by the conjugate of the denominator, which would be pretty much the same thing as the denominator, just with addition. It's always going to be just with the opposite sign. So it's not always addition. If it were addition here, it would be subtraction here, and so on. So you always do the opposite sign. This is multiplying by the conjugate on top and bottom. The reason we multiply by the conjugate on the bottom is because it'll be kind of it's the formula basically for getting all integers in the denominator. In other words, getting rid of all the square roots in the denominator. notice this has something like the form a minus b, a plus b. It's the opposite sign thing, the plus and minus, which leads to a difference of 2 squares in the bottom. So 1 times 1 is 1. Root 2 times root 2 is just 2. And that is the whole thing in the denominator. Like, that is what we get if we even FOILed all this out, because the middle terms would cancel out because of the plus and minus. So just the first term squared, 1, second term squared, 2, is what we get on the bottom. Again, this one just happened to be 1 because it was 1 times 1. Had it been like a 4 here and a 4 here, we would have gotten 16 here. Okay, so like, don't just think it's going to be the same as the number that was there. Does that make sense? So like, yeah, so 1 minus 2 in that case. Now we just have 5 times 1 plus whatever that. So we'll just do 5 plus 5 root 2. We'll distribute the 5, okay? And simplify it a little bit. We get negative 1 in the bottom. So it's basically just like 5 plus 5 root 2 over negative 1. So let's just negate everything. We'll call it negative 5 minus 5 root 2. And that's it for number 12. All right. Number 13, rationalize the denominator of the expression. Once again, we're going to multiply by the conjugate, but really that's actually just the square root in this case, so we'll just leave it as multiplying by that same square root of 5x. When we do so, we get 3x squared root 5x up top. Square root times square root leaves us with whatever was inside that square root on the bottom there. And we can simplify the x's. X squared over x is just x. And just leaves us with the 5 on the bottom. So I took this square, took that x like that. And I think that's it. I don't think we can do anything with that. So I will leave it like that. That should do it. That was a quick one. Hope that made sense. Let's keep it going. Solve the equation. Hint, let y equal x squared. All right, you heard the hint. We're just going to treat it as if, well, I guess I'll do y since they said y. So I'm going to call it 9y squared minus 46y plus 5. So what we're going to do is factor it with the y's, and then we'll plug x back in, and we'll solve. So 9y squared minus 46y plus 5. We have to solve for y, so we're going to factor. In order to factor, I'm going to do slide and divide. So I'm going to move the 9 over, multiply it to the 5 to get 45. I'm going to factor this like usual. Both negatives because we have a positive here and a negative here. So 45 and 1. We slided the 9. Now we have to divide by the 9. 45 divided by 9 is 5. 1 divided by 9 is no good, so we move the 9 up in front of the y, and we have these two factors. So what do we get? We get y equals 5, because we set y minus 5 equal to 5, and 9y minus 1 equals 0, so we solve for y there, and we get positive 1 over 9. So these are the y solutions, but notice we're looking for the x solutions, right? Because the original equation was x. Well, they tell us that y was x squared. That was the substitution we were using. So if y is equal to x squared, then, and we're solving for x squared equals 5, and x squared equals 1/9. Now we can square root both sides and find out that x will equal plus and minus the square root of 5. Because if we squared square root of 5, we get 5. If we squared negative root 5, we also get 5. Same thing here. Square root both sides. Square root of 1 is 1. Square root of 9 is 3. And then make sure to do plus and minus. Positive 1/3 squared is 1/9, and a negative 1/3 squared is also 1/9. So these are all 4 of our solutions. So negative root 5, positive root 5, negative 1/3, and positive 1/3. Oops. All right. Those are our solutions. We just got two more here, number 15 and 16. Let's write number 15 down here because it's gonna take a little bit of space. Okay, so when I write it down here, I'm going to go ahead and subtract 4x. So we'll have this square root equals 4x, negative 4x, sorry. And the reason I'm doing that is so that basically I'm trying to get rid of the square root, any square root throughout the entire equation. So what that entails is getting the square root by itself on one side of the equation and squaring both sides. So I would say typically if you have problems with square roots like this, you're trying to solve for x, get the square root by itself before squaring both sides. When we square the square root, we are left with what was inside the square root. When we square negative 4x, we get 16x squared. Negative 4 times negative 4 is 16. X times x is x squared. When we have an x squared situation, I always recommend getting all the terms on the same side of the equation so it's equal to 0, because more times than not, if you have an x squared and an x and a constant, you're going to either have to factor or use quadratic formula or something to solve for x. So we added the 16x, subtracted the 5, and now we have to either factor or quadratic formula. Use quadratic formula. So I'm going to use quadratic formula just because I don't know if this can factor or not. I don't think it can. I'm going to do negative b plus or minus square root of b squared, so 16 squared, minus 4 times a times c. A is 16 as well. C is negative 5, divided by 2 times a, which is 16. Let's figure out the inside stuff here. Inside the square root, we have 16 squared minus all that. I'm going to do it here. 16 times 16. It's going to be a plus 20 times 16. 576. I think that's a perfect square. Square root of 576 is 24. So what we have all together is negative 16 plus and minus 24 over 32. All of these divisible by 8. So negative 2 plus and minus 3 over 4. That's cute. And then let's split it up into answers. We have negative 2 plus 3 over 4. Negative 2 minus 3 over 4. So we get fractions. We get 1/4. And we get negative 5/4. Now what do we need to check for? Did they tell us? Extraneous solutions. They did tell us. So you have to check. You have to plug these in for x in the original equation. Not what we've squared, not this, but the original equation to see if the original equation still holds true when you plug in those x's. Because to solve an equation, to find the solutions, means you plug them into that equation that they're giving you, and it works out. So let me reiterate what we had. We had 1/4 and negative 5/4. So 1/4, negative 5/4. Let's open up Desmos. So this equation, let's use a's. So we'll do 5 minus 16a, or we could just, let's just plug it in. We'll do like this. I forget this is an option sometimes. 1/4, and then outside the square root, we add plus 4 times x, which is 1/4. So notice we are getting 2. Let me make sure I plugged it in right. Square root of 5 minus 16. Yeah. So I don't think that's a solution. I'm very curious if negative 5/4 is. So 1/4's out of here. Negative, is it negative 5/4? Did I mix it up? I just want to make sure. No, we have it right. All right, let's hope negative 5/4 is still 1. Look at that. Is that it? Yeah. Sorry, I should have clarified. We got 2 for the last one, right, in the Desmos calculation. But we were looking for all of this to equal 0. That's how we're like checking if the equation is true, okay? So we plugged in 1/4 and we got 2 instead of 0, so that's why it was wrong. And then here, we plugged in negative 5/4. and we got 0. So 5/4 or negative 5/4 is a solution, and it's our only solution, while 1/4 is not a solution because it led to 2 and not 0. Negative 5/4 led to 0. How could this happen? You might ask. Well, it might have satisfied this equation, the 1/4 that is, but the issue came from, I think, when we moved that 4x over, it became negative 4x, right? And then we squared it, and then it became positive. So, like, the issue is it becoming positive here when, like, initially when we moved it over, it was negative. So that kind of, sometimes stuff like that leads to trouble in terms of, like, having a solution being extraneous. Whatever. That was number 15. That's the process. Let's finish this off with number 16, and we'll get out of here. Find the values of x that satisfy the inequality. Okay, this is a fun one. So here's kind of the process for 16. Before I do that, I'm going to write it out here. Okay, we're finding the solution sets, all the x values that satisfy this inequality. What we want to do first is, let's get 0 on that right side. I think this is valuable to do because, I don't know, it just helps us follow a certain process where if we're doing these like rational expressions less than or equal to or greater than or equal to 0, it helps to get like all of this into just one big fraction instead of trying to like compare it to the 4 and yada yada. Okay, so we're going to treat this as 4/1, and we're going to treat this as two fractions we want to subtract, which means we need to multiply 4/1 by x plus 2 so that it can have the common denominator of x plus 2, and we can combine these fractions. So we now have x plus 2 on the bottom. We have 2x minus 1 minus 4 times x, so minus 4x, and minus 4 times 2, so minus 8. Okay, and we can simplify this first. So we'll get 2x minus 4x, that's negative 2x. We have negative 1 minus 8 is negative 9. X plus 2 greater than or equal to 0. Keep in mind it was still all greater than or equal to 0. So now this is really the inequality we're solving for. So how do we do this? Let's find the x values for which the numerator is equal to 0. And let's find the x values for which the denominator is equal to 0. Starting with the numerator here, so add the 2x, divide by 2. So negative 9/2 is the x value that makes the numerator equal to 0. When the numerator is equal to 0, divided by something, we get 0. So a 0 on top means the whole expression is going to be equal to 0. And we want to know where it's equal to 0, okay? So negative 9/2 will be part of our solution set, no matter what. Solving for where the denominator is equal to 0, we get x equals negative 2. When x is negative 2, the denominator is equal to 0, which means the whole expression, the whole fraction, is undefined, which means that's not going to be where it's equal to 0. And so we technically don't want to include negative 2 in our solution set. However, both of these x values, negative 9/2 and negative 2, will serve sort of as like boundaries. So we need to use both of them. Make sure to put them in order here, negative 9/2 and negative 2. They're both going to serve sort of as boundaries for the possible solution sets. So notice I've said y here. What I mean by y is this expression. That's just a nice shorthand I like to use. I'm basically treating this expression as if it were a function. Okay, so what I'm doing is saying that at negative 9/2 we know that y was equal to 0, because again, negative 9/2 made the numerator equal to 0, which makes the whole expression equal to 0. When x is negative 2, y was undefined because it made the denominator equal to 0. Okay, so now we're going to plug in x values left and right of these x values. So negative 9/2 is negative 4.5. So let's plug in negative 6. In between those, we could do -3. And to the right of -2, let's keep it simple, let's go 0. When we plug in, or what we're doing now is plugging in -6, 3, and 0 into this to get the sign. We want to know, is it positive or negative? Because then that will tell us whether this expression, or whether y is greater than or equal to 0 for certain intervals of x values. So basically, plugging in -6 is testing out this interval from -infinity to -9/2. Plugging in -3 is testing out this interval from -9/2 to -2. Plugging in 0 is testing out the third interval from -2 to infinity. So it's 3 possible intervals that we're kind of like gauging here. All right. Plugging in -6, we get -2 times negative, so we're plugging every x in there. So -6 times -2 is 12 minus 9 over -6 plus 2 is -4. So we get a +3 on top, a negative on the bottom. Positive over a negative is a negative. Now we plug in 3. -2 times -3 is 6 minus 9. -3 plus 2 is -1. We get a -3 over a -1. That's a positive result for plugging in -3. When we plug in 0, we get 0 minus 9. So we get minus up top. And 0 plus 2, that's a plus on the bottom, a positive. Negative over a positive gives us a negative. So what does this mean? The y values are negative up until -9/2, and then they're positive between -9/2 and -2. Then they're negative again after -2. We want to know where the y values, or where this expression is greater than or equal to 0. In other words, where is it positive or equal to 0? It is equal to 0 right at -9/2. It is greater than 0 from -9/2 all the way to -2, but not including -2, because -2 made the expression undefined, not 0. -9/2 made it 0. Okay? So -9/2 with a bracket to show that it is included in the interval, to -2 with a parentheses because we are not including -2 on the interval. This is the interval of x values for which this expression is greater than or equal to 0. In other words, for which this expression is greater than or equal to 4. And I think they wanted interval notation. Yep. So that would be your answer right there. All right. Hoo-wee. That was the entire review. Almost a whole hour. Pretty good. I'm going to scroll through just all the work we did today. And if you have any questions, let me know. Just get some clear images of these here. This was the Unit 1 review. Bunch of good problems here. A lot of simplifying, a lot of operations with fractions, a lot of common denominator, business. My dog is being very good, not barking at the dog outside while I'm recording this. Very good. Crushing it. Let's keep it going. I don't even know if you can see this at that point. I know it's a little blurry, sorry. Oh well. Let's keep it going. I'll work them out at some point in this video. Alright, that concludes this 1524 Exam 1 Unit 1 review. If you have any questions, please let me know. Email me, carterdmath@gmail.com. Someone send me the next practice test so I can keep making these videos. Alright, thanks so much for watching. Bye-bye.